Good morning, everyone. My name is Rodrigo Marcos, and I'm going to talk about Metasploit. The title of the talk is What You Didn't Know About Metasploit. I think it's very funny that the only word that I understood from the previous talk is Metasploit. Yeah, and Microsoft. Yeah, that's the two words, basically. So I think it was very funny. Well, let me tell you why I'm talking about this. Few months ago, I was developing some modules for Metasploit, particularly for exploiting SQL injection vulnerabilities through Metasploit. And I started discovering the framework. I think is quite undervalued. I think people think Metasploit is just for exploiting a remote vulnerability and getting a shell. So I was learning more and more about the framework, and I really like it. I thought it was awesome, and I was talking to my fellow pen tester colleagues, and I was talking to them and saying, well, do you know that you can do this with Metasploit? And they were saying, well, I had no clue. And again, and I think that people only understand like maybe 10, 20% of what you can do with Metasploit. So I thought this can be a fairly good opportunity to discover a bit more about the framework. Basically, I approached this talk in three parts. Basically, I'm going to talk a little bit about the framework as such. I discovered that the more you learn about how the architecture and the framework is developed, the more you can get from Metasploit, and the better you understand then how it works. So we are going to talk a little bit about that, and then we are going to talk about how to use Metasploit for exploitation, for post-exploitation, and that kind of stuff, privilege escalation, that kind of thing. And then we will focus a little bit on the development and automation that you can do with Metasploit. So well, let's crack on with the first part of the talk then. So, well, we are going to talk a little bit of Metasploit, the history of it, and the architecture. Okay. Let me actually ask you a question. Who is familiar with Metasploit? Who uses it like every day? Yeah, fair amount of. It's a very well-known tool. Most of the pen testers use it every day. But the thing is that people think that Metasploit is this. It's just choosing an exploit, setting a host, setting a payload, exploit, and that's it. And people think that that is like what Metasploit is about, and actually it's not. It's much more than that. Metasploit is a framework used for developing exploits, testing exploit, well, obviously executing exploit code. It's focused on penetration testing professionals, well, and it can be used for shellcode development and for vulnerability research, okay? So there's a lot of things on it. It's free, it is open source, it is de facto vulnerability exploitation framework. So basically, when someone wants to exploit something nowadays, uses Metasploit. It's fairly reliable, very well maintained, easy to extend, and it has lots of vulnerabilities and payloads. At the time of writing, it has like 708 exploits and 248 payloads, which is, well, quite a lot. This is a little bit the history of Metasploit. It was developed, first version by H.D. Moore back in 2003. The first version and the second version were written in Perl, and new exploits have been added since. The first version had a quite horrible front-end text base, and only 8 exploits on it, right? But from then on it grew, and in version 2.7 there were already 3 users interfaces and more than 150 exploits. And in version 3 it was it was rewritten completely in Ruby, and it was a fairly dramatic change on the framework. Okay. Well, just for the record, in the 21st of October 2009, Rapid7 acquired Metasploit project, but they said that they are going to it is going to remain free and open source. I thought it was quite interesting. This is the first H.D. Moore email that he sent to a security list when he released the first version of Metasploit. As you can see, there's only 8 exploits, and it was version 1.0, written in Perl at the time. I thought it was quite cool. Well, I'm going to talk a little bit about the architecture. As I said, there's a fair amount of differences between version 3 and the previous versions. I'm going to focus on version 3, which is the current one. It's written in Ruby. And therefore it's multi-platform, so you can run Metasploit pretty much in every single architecture which can run Ruby. Obviously all the major operating systems and also mobile devices, so you can run Metasploit pretty much in almost everything. It's very modular and is fairly well implemented, so it's very easy to extend it. It's very, very easy to write a new module or to extend the functionality of the console or anything like that. Okay? And has no dependencies, so you don't need any external libraries apart from Ruby. Everything is pretty much self-contained within the Metasploit framework. That is a graph of the architecture. So basically, we have some common libraries which implement pretty much all the socket handling, lots of libraries for exploitation, etc., etc. And then we have the modules that access those libraries. Okay, we have interfaces, we have tools and plugins. Let's focus a little bit on the libraries. They are, as I said, pretty well designed, and they encourage reuse of code. So you can use the same code for many exploits. They do that with Ruby mixins, which is a pretty cool technology, basically. It is modular, and the good thing is that they are just normal Ruby libraries. So if you want to write an exploit, but you don't want to implement a module in the Metasploit framework, you can just use the libraries on your own Ruby script, and you can use all the technology and everything within the framework, but you don't have to use the framework. You just use the libraries. Okay. Brief look to some of the libraries. This is the lowest level of the library, the Rex library, Ruby extension library. Basically, it includes all the socket subsystem, all the protocols used by the framework, the login, some of the exploitation utility classes, etc., etc. And it has no dependencies, right? Now, the MSF core, if you're familiar with exploit development, that is one of the libraries that you usually include on your exploits. It is, interacts with the exploit modules, the sessions, and the plugins, okay? And within the framework library is the lowest level, okay? And MSF base is a wrapper over the MSF core library. All the interfaces uses MSF base, and usually when you write an exploit, you almost all of the functions are MSF base library. Okay. Now this is all the modules on Metasploit. So this is when you use the MSF console. That is what you see on the payloads, all the exploits, the encoders, the knobs, and the auxiliary modules. We'll have a better look maybe afterwards. The framework, obviously you need to access somehow, and that is the user interfaces. There's a number of interfaces, some of them text-based and some of them are web-based, GUI-based. We'll have a look later. This is just from the architecture point of view. Now, the framework comes with a number of tools for, well, obviously a number of purposes for exploit development, for making your life easier, for automation, etc., etc. And those usually target the Rex library. And the plugins are, they're not like modules. Basically, those are designed to extend the functionality of the MSF base or the console, for example. Okay. Now, let's. This is the second part of the talk. Let's talk about the actual use of Metasploit. Okay. So we will go through the interfaces, the exploitation, web exploitation, and post exploitation. Now, as I was saying, there's a number of ways of accessing Metasploit. The web interface used to be very common in previous versions, but now, since version 3.3, that interface has been removed and is no longer maintained. Now, the framework now has, well, you can understand the web interface maybe of being like a collaborative infrastructure whereby you have your Metasploit host and then lots of people accessing it through the web. Now, Metasploit developed a really interesting way of doing that. Basically, they developed what they call MSF RPCD, which is basically an RPC daemon that you can set on a host, and you can access to it remotely, basically doing RPC calls. Okay, most of the GUI interfaces use this daemon to access the framework, but obviously anyone can use it. It allows authentication as well, so you might as well, if you have a pen testing company, you might have your Metasploit host with RPC calls, and then you can automate your processes, etc., etc. Okay. And there's a number of interfaces there which come with the framework. This is what they call MSF GUI, which is quite okay. Actually, I have to say none of the graphical interfaces are perfectly mature. And in my opinion, the best way of using Metasploit is the normal MSF console, which is, I guess, what most of us use. But well, the GUI interfaces are okay. This one is fine. You can scan hosts and it gives you the vulnerabilities. You can choose set and exploit, choose the target. It fills up most of the details there. You run the exploit and you get, for example, a shell within the GUI interface. I guess if for people with less experience, having a GUI interface can be quite interesting. And this is probably the best GUI interface. It's called ArmTouch, and it is quite nice. It implements a console at the bottom and a graphical interface. Once you go through your discovery process, all the hosts will be included in the top right side. When you compromise a host, it appears in red, as in the movies, and from there you can, well, keep working your way to other networks and stuff. So it kind of makes things easier in that way. This is how you attack. Basically, you get you choose a target and an exploit, and you launch it in a fairly graphical way. Well, I guess you are all familiar with the MSF console. This is just what I guess most of the people use. It's a normal client, text-based, but with a fairly good interface. don't know if you're familiar with MSF client. Anyone? Yeah, few people there. Well, this is a client that actually uses command line. You specify MSF client, you specify the exploit that you want to use, you specify all your arguments, okay, which will be your remote host, the payload that you want to use, etc., and then you execute, well, that exploit with that payload. Basically, everything is done in command line, so it requires no interaction from the user, which is really good if you want to script attacks. You don't need to enter anything, you just provide all the parameters in the command line, okay? So we have an example here. I don't know if you can read it. Basically, we specify the MSF client, the exploit that we want to run, the remote host we want to attack, okay, the payload we want to use, and then the E is execute the payload. So basically what it does, it executes the console with all the arguments that we provided. It starts as the handler for the payload to execute, and basically it executes the exploit and provides us the shell, which is the payload that we specified. Okay, so as you can see, there's no interaction. Just execute that. Okay. Now, obviously, a big part of Metasploit is exploitation and post-exploitation. There's more than 700 exploits at the moment, and those are most of them remote exploits, and some of them local exploits. Okay, I guess all of us are very familiar with remote exploitation. Okay, but well, we are going to cover here some of the cases. We are going to talk a little bit as well about the payloads, which is again one of the things that I think make Metasploit fairly powerful. And we are going to talk a little bit about the client-side exploitation, which is something that probably is not that common, well, not that very, that many people use it, okay? Well, remote exploitation is well, fairly simple with Metasploit. It's basically choosing the exploit that you want to use, choosing the target, choosing the payload. The payload is the code that you want to execute once you gain access of code execution in your target, okay? And then just exploit it. It's as simple as what you see here in this screenshot. So basically in here, we choose here an exploit with the command use, okay? Fairly simple. And then we set a number of variables. Basically, we set the remote host that we want to attack, okay? The payload that we want to use, in this case, is just a shell binded to a port, okay? And then we exploit it, and basically, the framework, well, in this case, is the didn vulnerability. It accesses the host on port 135, sends the exploit, and opens the session, okay? As you can see, it's fairly simple. I guess that's what we are all familiar with, okay? Now, some of the interesting things about Metasploit is that it allows you as well local exploitation. By local, I mean what you can do is you can exploit a remote host, and maybe you are not getting enough privileges. Maybe you are using it through SQL injection, and you have only the permissions of the web server or something like that. Well, Metasploit allows you to do privilege escalation exploitation on the remote host using a local vulnerability on the remote host. Okay, for doing that, obviously, first thing you need to do is to gain some kind of access on the host. And after that, what you do is you send this local exploit, channeling it through your exploited host. Okay, it's a fairly simple process. Basically, what you have to do is you have to run a Metasploit. We will speak about that later, and then it's basically about using one of the post-exploitation Windows escalation vulnerabilities. Okay, it's as simple as that. You use the exploit, and then you set the session where you have your Metasploit running. Okay, and then you just exploit it, and you gain further privileges, and basically you do a privilege escalation. Okay. Now this, I guess. Remote exploitation is what we all do, but there's a few interesting things, and one of them is auto-pawn. I don't know if you're familiar with this. Basically, what you can do with this is just a script around some of the functionality of Metasploit. This script, what it does, you need some database support. Okay, so the framework comes with support to MySQL database and Progress SQL database and SQLite. Okay, so once you set up that, you have some other functionality. Okay, within the framework, and you can, for example, scan some hosts, and everything will be recorded, and the open ports, etc., will be recorded on the database. And then what you can do is you can use DB auto-pawn to try every single exploit on every single, matching certain port, and then on all the hosts that you want. Okay. In an automatic way, so you don't have to launch anything, any exploit. You just do the auto-pawn script. Okay. So this is a very quick example. So the first thing you have to do is you need to import the hosts into Metasploit. There's a number of ways of doing that. So normally in a pen test, you would have run Nmap, and probably you have the results on an XML file. You can import that file. You can import all sort of other files like AMAP files. You can import Nessus scans. You can import even Qualys scans, okay, into Metasploit. So in the example that I have here, actually I chose to run Nmap from within Metasploit. It's calling your external Nmap on your system, basically. Okay, so you do db Nmap, and then whatever arguments you want to pass to Nmap, so you can scan a whole range or whatever. In this case, I just scanned one host, okay, with a number of ports opened in here. So all the results from here are recorded and are stored within Metasploit, okay, and the framework will know that there's one active host with a number of ports opened, okay. And then what it will do is it will run against port 80 every single exploit whose default port is 80. It will run on port 135, 139, 445 every single exploit, with that default port. Okay. Basically, in this specific case, and taking into account that there's a fair amount of open ports, Metasploit found 189 potential exploits. Obviously, lots of them wouldn't work, okay, because that specific host wouldn't be vulnerable to that exploit. So, for example, on port 80, it will try lots of exploits for technologies which were not installed on the host. So the script actually doesn't do any enumeration of the services or anything. Just based on the port, it will launch everything. Okay. But well, basically just with one command, which is db autopon -p is so that it matches by the port, and -e is exploitation. It will launch automatically 189 exploits, and well, and 5 of them were successful. So we found that we could compromise that particular host in 5 different ways. Okay. Now, once you compromise a host, you can choose what kind of code you want Metasploit to run on it, which is basically the payload. Okay. Well, in the framework, there's 3 different payloads. There's what they call single payload, okay, stage payload, and a stager. Basically, a single payload is just a self-contained piece of code that handles communication, okay, back to the attacker, okay, and it handles whatever code you want to execute. So you don't need to run anything else. It's just self-contained single payload, okay. Now, sometimes when exploiting a host, we have some size constraints. So a single payload, depending on the code that you want to execute, but in general terms, is fairly big. And sometimes we cannot run a single payload against a host. Okay, so sometimes what we need to do is to send what is called a stager, which is a tiny or a small piece of code for exploiting that, and then that stager will get back to us, to the attacker, and then we will send another piece of code. Okay, that is what is called a stage payload. Okay, the stage payload is connection independent because the connection side of the exploitation will be handled by the stager. Okay, and basically when we use stage payload, we first send the stager, and then the stager communicates to us, we send the other exploit, but everything is handled by the framework. Okay, we don't have to care about that. Okay, and the stager is, well, the piece of code that that glues the exploit and the stage. Basically, it tells how the exploit will communicate. Okay. Well, there's at the moment there's 248 payloads, which are a lot. Obviously, the payload is a piece of code and is dependent on the operating system and the architecture. And there's a fair amount of, and as well the technology, there's a fair amount of range of payloads to choose from. It covers, well, most of the operating systems. And it even runs on iPhone, so there's payloads for getting a shell on an iPhone, but there's obviously for Windows, Unix, Linux, Mac OS, etc., and for different architectures as well. Okay, so it runs on 32 bits, on 64 ARM architecture, etc. Now, it's becoming more common to have payloads running on different technologies and architectures like Java, JSP, PHP, or ASP, and actually the Metasploit has been ported to PHP and ASP. Okay, and there's another thing. Maybe a couple of years ago, there were a number of modules implemented on Metasploit which were exploiting wireless drivers. Now, when you exploit that, the exploitation techniques are slightly different because you are running on kernel mode instead of user land. Okay, and for doing that, the Metasploit guys developed a wrapper for kernel mode payload, which is interesting approach, because you can run then all the user land payloads that exist on Metasploit, but on kernel vulnerabilities, kernel land vulnerabilities. Okay. Those are, well, the basic handles that you can set up on a payload. So when you exploit a vulnerability, you can choose whether you want to have to access your payload through the network in a different way, right? So, for example, typical ways bind your payload to a local port on the host. Okay. Obviously, this has some disadvantages. If you have a firewall between you and your target, probably that firewall will be filtering most of the connections, so this payload would not work. Usually, what you can do is you can do a reverse TCP payload connect back to you, okay, which in general is network filtering is less restrictive, okay. And there's some other interesting payloads that people don't usually use. So, for example, what they call reverse HTTP or passive X. In a very restrictive environment, you might find that there's absolutely no way that you can establish a connection between your compromised machine and your host. Okay, it might be because there's no such access. Maybe that machine is only maybe accessing the internet through a proxy or something like that. In this case, you can use what is called this passive X payload, which is actually an active X that uses Internet Explorer settings to load an active S and to channel the exploit using HTTP traffic back to you, which is a very interesting way. Also, there is what is called a reverse TCP all ports, which again is a very interesting approach. When you compromise a host, you might not know what kind of outbound traffic restrictions are. So this payload tries every single port back to you. Basically, the first part of the exploitation, the stager, receives a number of the port, and then it tries to connect back on that port. Okay, your attacking machine will be listening on each port and trying to get the shell back. Okay. All of the exploits, all of the payloads also support IP version 6 for listening and targeting. Okay. Now, so once you have the exploit, you have the handle, you choose basically what is the type of exploits. So, well, I guess it's a personal preference, right? But usually what people do is get a shell on the box, or depending, you can add a user as well. If there's size restrictions, you might not be able to execute some payloads. For example, adding a user is a tiny shell code, so you might need to choose that. But well, there's other stuff like downloading a file and executing it, executing a specific command, which is in the operating system. Okay. Many of the payloads use a technique, very well known and exploited technique called reflected DLL injection. So, for example, VNC injection and Metasploit uses that, okay? Which means that you can inject an arbitrary DLL on the exploited process, okay? Metasploit comes with a number of DLLs like VNC or Metasploit, but you can code your own, and you can choose, you can set up Metasploit to inject that DLL into the exploited process, okay? There's other payloads like uploading a binary and then executing it, okay? Now, there's also in Metasploit some client-side exploitation. This is obviously becoming more and more common, right? Because lots of corporations put quite a lot of effort into protecting the external interface, but sometimes they forget about the workstations. Okay, so there's a number of exploits for exploiting Office and PDF files, and also obviously the web browser. Okay, in all of them you can execute whatever payload is supported by Metasploit. Okay, so I found, well, I'm going to explain two interesting approaches to file backdooring, well, or client-side exploitation that I found quite effective, actually. The first one is the PDF backdooring. So Metasploit can embed any payload into a PDF file. Okay, depending on the version, it will be executed automatically, or it will warn the user, or in latest version, the security policy might be configured not to execute that. Let me show you what I'm talking about, basically. So let's see. Well, so we have in here So we have a normal PDF file in here, okay, which is just the user guides of Metasploit that I'm sure you all have read at some point. So what we are going to do, we are going to create a version of this PDF file with payload embedded on it, right? So we have Metasploit, the MSF console running here. Let me just copy and paste this. Oops. There is an exploit which is Adobe PDF embedded exe, right? We good to have a mouse mat. So we choose a Metasploit reverse TCP shellcode, okay? If someone has a mouse mat, I would really be very glad. I would invite a beer to anyone. Oh, thank you. So what we are doing here is, as this is a reverse payload, it will connect back to us, so we need to set up the local host, okay? And so this is our IP address where we will be listening to that payload. And then we set up basically the file that we want to inject the payload to, and then we just exploit it, okay? So basically, it will generate a file called evil.pdf, okay? And now, what we are going to do, well, through social engineering, we would send that file to whatever target we want, okay, which could be by email or downloading from a website or something like that, okay? And we will be basically setting up a handler to listen to that connection, right? So now imagine that we are on our victim host, okay? Oops. So we are in our victim host, okay? And we send this by email, okay? So basically, it would open the file. And we will say, well, this is an encrypted file, just click open, okay? And as we can see, the payload is executed, and we get a session on the user's host. So basically, so we get a Metasploit running through the PDF file, okay? Now, there's another version of that attack. Basically, it would be backdooring a file on a .exe, okay? So Metasploit can embed any payload in a file. And what you do is you specify the .exe file that you want to backdoor. So for example, in this case, it's calc.exe, okay? So Metasploit will create a file called evolcalc.exe, and then when executed, it will, so we set up the handler again. The user will again be executing the file as such, and as well the Metasploit session back to us, okay? So this is a way of backdooring files and PDFs, okay, for client exploitation. Now, there's some other stuff that you can do from the client side with Metasploit, okay? Some of it is using exploits targeting the web server, okay? Let me show you what I'm talking about. Let's do, well, browser autopwn would be the equivalence of the previous autopwn that tried all the vulnerabilities, but this one is only trying vulnerabilities within the web browser environment, okay? So let's exit this, okay? So for browser autopwn, what you do is so you set the path where you will be serving your payloads, okay, for all your web browser vulnerabilities, okay, and it's going to take a while. And then now the framework, what it's going to do is it will check all the web vulnerabilities affecting web browser. So that includes Firefox, includes Chrome, includes Internet Explorer, etc., etc. And what it will do is it will set up a web server with all those vulnerabilities, okay? And when a victim connects to your attacking web server, it will deliver all the payloads, okay? Whatever the server is. So in this case, we are adding Mozilla, Java, all the vulnerabilities, Opera. So all the vulnerabilities, Safari, included in the framework will be delivered to the attacking host, to the victim, sorry, should I say, okay? And so in this case, 19 exploit modules are served on our host, okay? If you want, feel free to connect to it. It'd be interesting to get a shell there. So, and now what we have to do is if we send an email or we redirect somehow our victim to our malicious web server, right? So in this case, we receive the connection. We check that actually this is vulnerable to the create object code execution exploit for HTML, okay? And, well, the browser crashes, but it actually created a session 3, so we can interact with it. And as we can see, so we got a shell again on the box, okay, using this client-side exploit, okay? Let's crack on with the presentation. Oops. Oh, sorry. Okay. So now, web exploitation. Typically, Metasploit has been only targeting infrastructure testing, but lately it is more common to use it in the web environment. Okay, there's a few concepts that I'm going to explain. The first one is that you can get a metapreter, okay, with working with PHP and ASP. So when you discover a vulnerability whereby you can upload arbitrary content maybe to your website, usually what we used to do is just have a normal web shell with certain functionality, but now we can have a working metapreter, which is actually, it doesn't include all the functionality of the normal, the binary, but it includes quite a lot. And well, this is the way we create those files from the Metasploit payload binary. We have the PHP metapreter reverse. Okay, we set the options, and we would just upload that file to a PHP host. And the same happens with ASP. Okay, we would do that with MSF encode. Okay, once we upload that, then we would just, with a browser, we would execute the file, and we would get the metapreter back to our attacking machine. Okay, so this is an example of it. Okay, so we create the file. Okay, and we upload it to the server, and then from a web server, from a web browser, we visited it, and we get the metapreter. Okay. There's also some functionality for exploiting remote file inclusion. Okay, so when there's a vulnerability whereby we can execute any arbitrary inclusion, okay, we can use what is called the PHP include. Okay, and again, we can specify any payload, and it will be delivered through the PHP include. Okay. Now, there's more and more modules now for exploiting SQL injection vulnerabilities from within the framework. Okay, I coded a wrapper a few months ago for exploiting MS09004 using this. Let me show you how it works. So imagine we have a web app. Oops. So we have a web app, and we identify a SQL Server vulnerability, right? So for example, if we type that, we identify that there's an issue here, okay? And in this case, we identify that with a semicolon, we could do any arbitrary SQL code in here, okay? Which cannot be very useful maybe here from this attacking perspective, but it could be very interesting if we want to exploit the MS09004. For whoever of you who are not familiar with the vulnerability, that exploits SQL Server vulnerability in a function which is called replace write to var bin. Okay. I wrote this wrapper for using it with SQL injection, so you don't need to have any authentication. It doesn't require any authentication. Okay. Let me show how it works. So basically, we choose the exploit, okay, and we choose the host which is vulnerable to the SQL injection, and we specify the SQL injection part like so, okay? So Metasploit knows that it needs to execute the code within these brackets, okay? We set up the handler, and we set up our local host to listen to the metapreter coming, and basically, if everything goes okay, everything will be done through SQL injection. So this is not like infrastructure testing, it's SQL injection, okay? It's sending the payload. hopefully. This can be one of those famous demo effects that everything goes terribly wrong, right? It's looking like it, actually. It should have worked already. Well, I said that I coded this wrapper. Actually, that was a joke. I haven't. Well, it could be, well, it could be anything, really. I would say let's crack on with the presentation. Oops. Right, well, assuming that that worked. Now, this is one of the most interesting parts of Metasploit, okay? The post-exploitation is extremely powerful. You can do lots of stuff once you compromise the host, okay? Lots of stuff that makes our life so much easy, okay? Some of them, we are very familiar with it, but we can make our life very easy with this. So one of them is the hash dump. So we don't need to upload pwdump to the host, okay? Now we can just have a metapreter and having all the hashes with them. And afterwards, we can use the hashes with PSSEC without even cracking them, okay? I don't know if you're familiar with Incognito. It's a really cool tool for token manipulation. So if we compromise a host in a local environment, we can jump to the domain administration, using Incognito. So all the functionality has been built in within Metasploit, okay? And we can impersonate users there, okay? We can sniff traffic. So again, once we have Metapreter running, we don't have to upload any sniffer. We can just sniff the data, and we can even set up filters as we would do in any sniffer, okay? This is a very interesting one, a smart locker. So imagine that you compromise a host and you really want the password of the user locked on, okay? You cannot crack it, you cannot do anything. So what we would do in that case, that didn't work. Let me set the handler again. I'll show you. So let's assume we have, a metapreter running here, okay? And we want this guy password, okay? So what we do is, so we do, smart locker. Let's do. And what this process will do, it will migrate the metapreter to the WinLogon system, okay, to the WinLogon process. And what it will do is it will lock the screen after a number of seconds that we are specifying, in this case, 10 seconds, okay? So the user, after 10 seconds of inactivity, will have the screen locked, okay? Let's wait a little bit. And so when the screen is locked, it will run a keylogger, it will get the password, and it will show it to us. Hopefully. It's another demo. Okay. We will get back to that. Okay. So, well, this is an example of that running. Okay. Basically, it runs the keystroke sniffer, and then when the user unlocks and sets the password, it will show the password to us. So it's a very, very interesting way of getting the password of the user. Okay. We will do that. Privilege escalation, very powerful. We can get system level using a number of techniques. We're running out of time, I think. And a very, very interesting thing is the pivoting system, that once we have one host compromised, we can very, very easily keep compromising other hosts. There's a number of ways of doing this. Port forwarding is a very interesting one. So if we compromise victim 1 in this case, and we want to access victim 2, but we cannot do it because the firewall is filtering that, we can use something like port forward, add, and then our local port on our machine, and then the remote port, which would be the remote port that we want to access, and the victim 2 IP address. And in that case, it would create a tunnel, okay, and we would be able to access the victim 2, okay? Very powerful. But we can do that only for one port. In this case, what we can do, more interestingly, is to add a new route to our network routing table, okay? Like you can see here, okay? We add a route, and then every exploit will be routed depending on the rules, okay? One thing we can do is to route all the traffic to our target network, for example, on session 1 of a Metasploit, okay? And that would allow us to keep exploiting things. But that would only work within the Metasploit framework, so not the other traffic. It will not be routed through Metasploit, which could be very interesting, and that's why we could set up what is called a SOX proxy, okay? So in this case, what we can do is we can channel all the traffic through a SOX proxy on a Metasploit version, and then using proxy chains to run Nmap or whatever we want. So this would be an explanation. The attacker could run any command through this channel using a SOX proxy, okay? Oh my God, okay. So, and last part of this talk is the development and automation that is going to be quickly. So we can automate a number of things here. If we execute MSF console with the -r and then a script name, we can very easily code a script for Ruby. So in this case, I have this very simple example that basically it scripts all the things that we do just in a file, and then we can even include some Ruby code in there, okay? So this is an example of that running. So we execute MSF console and then the automation file, and it does all the exploitation and it executes the Ruby code, which could be very, very interesting for testing and automating stuff, okay? We can create also scripts for Metasploit very, very easily. So in this case, we can do, for example, print a status hello world into hello world Ruby here, and then very easily we can just run it from the Metasploit and it will execute on the remote host, okay? There's a number of tools for helping exploit development. So this is one for getting opcodes from binary files, in this case, okay? And again, some tools for exploit development. So we're going to crack on. Shell generation. And then it is very easy and it's very well documented creating scripts using the libraries of MSF base, etc., etc. Is what I was talking about. You can just use the libraries yourself, okay? Without having to use the Metasploit framework. You can just use the libraries, okay? This is how exploit module looks like. It's very, very easy to do. Everything is Ruby, and you can use all the libraries within the exploitation framework, okay? Just a few conclusions. I would say Metasploit, we only use like 10-20% of what Metasploit can use. It's very easy to extend, it's easy to learn. Very, very powerful post-exploitation features, okay? And well, that's all. Thank you very, very much to the AthCon crew. It's been fantastic being here again. Thank you to the audience, and I would welcome a question. No questions? Oh, thank you.
Okay.